Hello everyone, welcome back to session 6 of Statistics for Data Scientists. And in today's session, this is the part 4 of our inferential statistics. In our previous session, we have already covered Z test, T test, and in today's session, we will talk about the Annova test. Okay, so the condition that we have seen for Z test and T test with that, in Z test was applicable when the population size when the sample size was greater than 30. Okay, and the standard deviation was known. So under that condition, we used to implement z-test. T-test was applicable when the sample size were small and standard deviation were unknown. So these are the two conditions for these two tests to be applicable. Now, one common condition for all the tests was that generally we used to implement all these tests on a normally distributed data. Okay, now ANOVA test, which is also known as F test. Okay, ANOVA is known as the analysis of variance. Okay, so it is an statistical method which is used to test or compare the means of three or more groups or population simultaneously. Okay, so basically the agenda of ANOVA is to compare the means of three or more groups or population at a time. Okay, it helps in assessing whether there is any significant difference between the means of group based on the variation within and between the group. Between the group, we used to compare the variance among different features. Okay, between different features, and we even, like, with the help of ANOVA, we even used to compare the variance within a particular feature itself. Now, within a particular feature itself, it means that we can have a different group within the range. Okay, so we used to find the variance within those group. Now there is some conditions. We have certain conditions for ANOVA. Those conditions are that, like, it must have a continuous response variable. Okay, there should be a continuous response variable. Number two is there should have to be at least one categorical feature, and the common condition was that the distribution should be normal. So these are the common condition for ANOVA test. Now we have now ANOVA. Basically, we have three types of ANOVA. Okay, we call it one-way ANOVA, two-way ANOVA, and a repeated measure of ANOVA. Okay, we'll come to this. So, and ANOVA was developed by a statistician known as Ronald Fisher. Okay, so we have a evaluation metric called Fisher score. Okay, so based on Fisher score, we decide what is the is there any difference between the significant difference between the mean of uh, mean of mean of the groups, okay, or the population. Okay, it is with the help of Fisher scores that we need to decide. Now, now ANOVA. Okay, so ANOVA is also known as ANOVA, which is also known as F test. Okay, um, analysis of variance. And the types of ANOVA that we have one-way ANOVA, one-way ANOVA, two-way ANOVA, and we have the repeated measures of ANOVA. Okay, so yeah, so basically, one-way ANOVA. Okay, so in one-way ANOVA, we compares the mean of three or more independent groups on a single continuous outcome variable. Okay, so for an example, let us take an example of mean exam score of a student from three different schools. Suppose in a city we have three different schools: school A, B, and C. Okay, so their math scores would be obviously the mean of the math The school math score is scored by the school A. Let us talk about their mean value is 85%. Okay, the math score of school B would be 87% the mean value, and for C it is 95%. Okay, so when we compare the mean, when we will compare the mean value among these independent groups, then it will be a one-way ANOVA. So in two-way ANOVA, we compares the mean of group across two independent categorical variable simultaneously. Okay, so we are, yeah. So in this case, we are comparing the group across two independent categorical variable. For example, let us take an example of the patient recovery time. Okay, so patient recovery time. So in that case, let us take the feature one as treatment time. Okay, and feature 2 will be gender, and feature 3 the recovery time. Okay, now in this case, gender will be male, male, female, right? And treatment like cataract cataract or hypo syndrome, or we can have any other treatment. Okay, any other related. Now, uh, these two, the treatment type and the gender type, they are the categorical variable, right? So, combinedly, what is their impact on the recovery time? Let us take an example now itself. Okay, let me see whether we have an example. Okay, now in this case, we have three types of fertilizer. Okay, three types of fertilizer are used on three groups of plants for 5 weeks. Now we want to check if there is a difference in the mean growth of each group. Using the data below, apply one way ANOVA test in at 0.5 significant. Now you can see that we have three different fertilizer: fertilizer one, fertilizer two, and fertilizer three. Right, and yeah, okay. So. So basically, when we have to apply the hypothesis testing, okay, so our assumption is that, so step one will be the formulation of, yeah, yes, step one, right? It is the formulation of hypothesis. So you know that H naught in this case, the null hypothesis, okay, it will be equal to the group one mean value will be equal to group two mean value, right? Means are equal. We are assuming that means are equal. Means are equal. And for alternative hypothesis, we are assuming that means are not equal. Not equal. Okay. Now in this case, if we will try to calculate the mean of all the fertilizer, so let us, so 68453. So it will be 5.2. Okay. And similarly, this will be 9.2. And so it will be, this will be almost 3. Okay. So in this case, mu1 equal to 5.2, mu2 equal to those 9.2, and mu3 equal to 10.6. Okay. Let's just do this part only. Okay. Now in this case, so our total mean. If we find the total mean is equal to 5.2 plus 9.2 plus 10.6 by 3. Okay, so this will almost become 8.3. Right? So this is the total mean. Now we will calculate the sum of squares because we have to calculate the F ratio. Remember that. Okay, we are going to compare the mean, okay, among with respect to each individual attributes or the features. Okay, not sum of squares. Sum of squares between the group. Okay, in this case, what we will do? Yeah, so our values are 5 into 5.2 minus 8.33 whole square plus 5 into 9.2 minus 8.33 whole square plus 5 into 10.6 minus 8.33 whole square. So here the is sum square between the groups will be 17.78.6. I have already calculated it. Okay, now the sums we have to find the sum of a square within the group. This is between the group, right? Sum of squares within the group, right? The group between the group. Okay. Now in this case, since W will be it will be equal to okay. So let us calculate the value. So P what are our values? 6 minus 5.2. Okay. So 6 minus 5.5, 6 minus 1.2 whole square plus 4 minus 8 minus 5.2 whole square plus 4 minus 5.2 by 5.2 whole square. Right? 2. We have 8 minus 9.2 whole square plus 12 minus 9.2 whole square plus 6 minus 9.2 plus in the last one 14 minus yeah, 10.6, right? 10.6. So this I have calculated and it is almost equal to 47.6. Now, see, since the standard deviation is not mentioned here, okay, so we have to let us find the degree of freedom. Now, the degree of freedom in this case will be n minus 1, right? So we have three features. So 2 minus 1 is system. So degree of freedom between the group will be n minus 1. N minus 1 equal to 2. The degree of freedom within the group will be n minus 2, and that is equal to, and n value, our n value is the okay, so okay, it will be 5 into 3, right, and minus 3, so it will be total 12. Okay, so basically it is nothing but the number of observations in this case. Okay, in the first case it is the number of attributes, number of observations for this number of attributes. Okay, now we have to calculate the mean square value. Okay, now the mean square value, the mean square between the group is nothing but SS1 degree of freedom in the group. So that is, we have received 78.6, right? 78.6 then by 2. So it is 38, right? 39.3. And then between the group, it will be SSW by degree of freedom within the group, and that will be 47.6 by, we have 12. So it will be almost 3.97. Okay, so this is our mean square value. Now the F ratio. Now the F ratio is between the group and within the group. Okay, it is nothing but mean square between the group and mean square within the group. So the mean square between the group is nothing but 39.3, and within the group is 3.97. So it is almost 9.90. Now, so for alpha, so now see, for alpha the significance, see again, since we don't have the significance level available in the, okay, we already have the significance level. Okay, now in this case, the significance level is already given, alpha is equal to 0.05. Okay, so for significance for alpha is equal to 0.05, and degree of freedom within the group, which is equal to 2, and degree of freedom within the group, which is 12. The critical value, if you try to find out the critical value, okay, the critical value will be, from the table we have received it as, from the table what we have got is 3.89. Now since the F ratio value is 9.90, okay, which is greater than, okay, now F ratio F ratio and critical value, right? F ratio is 9.90 and critical value is 3.89. Okay, if ratio is greater than, okay, so therefore we are rejecting the null hypothesis. Okay, we are rejecting the null hypothesis. If ratio is greater than the critical region is greater is greater and and it's not in the rejection region. Rejection region. So so we reject null hypothesis. Right. So from here. In the step one, we are considering that the mean values are equal for all the attributes one, two, and three. Okay, and the for alternative hypothesis, I'm sorry, in this case, okay, so yeah, so the null hypothesis, we are considering that all the means are equal, and for alternative hypothesis, it is not equal. Okay, then we have to find the mean of each and individual group. So we calculated the mean of individual group, and then we try to find out the sum square between the group and sum of the squares within the group. Okay, so we calculated the sum of square within the group and sum of square between the group. Right. Yeah, so this 5 is nothing but the number of observations. Okay, when we are trying to find the number of sum of the square within the group, this 5 is the number of observation, and then we find out the difference between the each and every, yeah, difference between the data point and the mean value. Okay, similarly, we are finding the sum of square within the group, right? And then we are calculating the degree of freedom within the group and degree of freedom uh, within the group. Okay, for between the group it is n minus one, and within the group it is n minus k. That is number of observations minus the attribute value. Okay, so if for the for between the group it is just 2, and within the group it is 12, right? 5 is the number of observation into the attribute value. 5 into 3, 15 minus 3. Okay, and then the mean square. Now we are finding the mean square for mean square. So mean square will be the sum of square by the degree of freedom. Okay, we calculated for between the group and within the group, and then the f ratio, it is the ratio of mean square between the group and mean square within the group. So we calculate the f square, which we received as 9.90. Now we already have the critical region given in the question, that is 0.05. It's 0.05. Yeah, 0.5. Sorry. I think no. There is some mistake. It should be 0.05. It should be 0.05. Okay, and okay, for the significance level 0.05. Okay, and when we have the degree of freedom to within the group and between the group, okay, the critical value that we have received from the table is 3.89. Now the if ratio is greater than the critical region. In that case, we are rejecting the null hypothesis. Okay, we are rejecting the null hypothesis. Now let us see if we have any other example. So okay, so we are done with ANOVA test. Okay, in case what I will do, that I will attach some of the questions along with the solution and explanation. In case if you have any question or query, please drop your question in the comment box. Okay, so that's all about this session. So we have covered the ANOVA test, Z test, and T test. Right. In the next session, we will see the p-value in statistical hypothesis, and we will also discuss about the chi-square test. Okay. So thank you for now, and please do subscribe to our channel.